this is Monday, and so is our graph class. So we're going to be looking at last week. We went through the basics of the coordinate plane. I introduced you to, what is a coordinate plane, or it's called a Cartesian plane, and that is the graph paper. That's what we call the graph paper. The Cartesian plane shows your axis, your x-axis, your y-axis. It shows the scale along those axes, whether we're going up by 1 unit or 2 units or 5 units. Each axis has its own scale, or they might have the same scale, depending on what we have to plot, what coordinates are. So the coordinates are a set of values that are in brackets, and the coordinates tell you where to move on the x-axis and where to move on the y-axis. Before I go any further, I'm going to take a minute to invite us. In the meantime, I'm going to play a promo with the schedule for the live classes. So just watch that until I get back. I'm going to run out and invite everyone. I'm going to shout it from the mountaintop and come right back. Hello, CSEC students. I know you are preparing math test and your CSEC exams. I have a very, very important question to ask you. Thank you. My name has. Thank you. No, another important question. Have you ever done a problem simply because of making one little mistake? Sure, you have thousands of other students. Now you're going to be looking at the common mistakes that students make with all the tricks. We're going to look at common errors, demystify everything. Make sure you watch every video in this series to avoid making those mistakes. So, stay with it. Hello, scholars. Most times when students get. Hello, scholars. Did you know that most times when students get error or one problem wrong in mathematics as a result of one mistake? Well, this is absolutely true. We're going to be looking at the common errors that students make in the different topics in mathematics. All right. All right, students, we're going to be looking at something called GeoGebra. It's a software. It's a mathematics software that you can use it for graphing, you can use it for geometry, for algebra. No, this is by no means a tutorial on GeoGebra because I myself have not mastered GeoGebra. I don't know all the features of GeoGebra. However, I want to share with you the software, and we will be using the software to do our graph, to do geometry, and our in some cases. So I'm going to introduce software to you, and you can go ahead and download the software for yourself and use it when you are doing your own thing and your geometry. So it's a very useful tool that I'm going to share with you before we go into actually plotting, or what I would want to be plotting this evening is the linear graph. And we're going to actually use a linear function, and I'm going to show you how the graph to get its line. Now, as the name suggests, the linear graph will be a straight line, whereas the quadratic graph will produce a curve, which is known as a parabola. We're going that tonight. We're going to use the board and plot a linear graph, show you how to set up your table for the graph and to plot it. And it come off. So I'm going to share the screen with the GeoGebra. Where is it? This one. And show you what I'm talking about, right? If you see the GeoGebra screen, just let me know in this. So that I'm not talking to myself and I'm the only one seeing it. Alright, so you're able to see the GeoGebra screen. Let me see the charts. You're not seeing the screen? Okay, alright, so it's the screen. Alright. Now here's what I want you to tell me. I want you to tell me if sorry, wrong screen. GeoGebra. I want to tell me if when I'm moving the if you also see it moving up and down, because that's important. I'm going to be using it to point stuff out. So tell me if you're seeing me move the cursor up and down. Just do that for me. Give me some feedback. Are you able to see? Say I can see the cursor or not. When I was moving it a while ago, it was all right. Let's see what we can done still. So, like I said, it's not a tutorial because I'm still learning the ropes. But I want to show you. So this is you could call it the home page, and you have options up here. You can go to different use different tools, a host of different tools you can use. So right now I'm using the grid and plane. As you can see, so you can move it up and down where you want it. You want the x-axis further up or further down, or y-axis further to the left or right. You can move that. Now you can look at Cartesian plane here. So here we have the x-axis all the way across. This horizontal line, x-axis, and at 0, 0 origin, that's dead center, bullseye. That's where it all begins. Now, for this Cartesian plane, scale is the same on the y-axis and the x-axis. So it's 1 unit to 1 centimeter, or 1 unit, same. So along the x-axis, this is your positive x-axis to right. So from 0 out, 1, 2, 3. Notice that each intersection is where with the number in the middle, not in the space. At the point of intersection is where we put our numbers. From 0 to the left axis, these are your negative x values. From 0 up on the y-axis, these are your positive y values. From down, these are your negative y values. Now, I'm going to plot some of the more common lines and curves, also just to show you what it looks like. So let's start with the line y equal x. So down here at the input on the GeoGebra taskbar, you would put in the equation or the function y equals x. That's your function or your equation, and enter. That's the line. So the GeoGebra has drawn the line for you. This is the line y equal x. Now it's a line that through the origin, point 0, 0. What's about this line is that for each x value, the y value is the same. Hence the name y equal x. So when x is 1, y is 1. X is 0, y is 0. X is 2, y is 2. X is 10, y is 7. X is negative 2, y is negative 2. X is 5, y is negative 5. So this line, as you see it, you must be able to identify this is the line y equal x. Now I'm also going to draw the quantity x and show you what that looks like. So that input y equals negative x. And that's y equals x. Now what do you notice about these two lines? They are opposites to each other. They are the inverse of each other. So this one is the line y x, and this one is the line y equals negative x. That means whatever y is, x is negative of it. So when x is 1, y is negative 1. X is 4, y is negative 4. X is negative 3, y is 3. X is next, y is 6. So whatever y is, x is the opposite of it. This line also passes through the origin, but look at how it's inclined. Look at the orientation. For the line y equal x, it's oriented to the right. For the line y equal negative x, it's oriented to the left. All right, so let me clear this. All right, have my grid again. Back in the center. Back my grid. Now I'm going to show you the quadratic curve, which is called a parabola, and the general, just simplest quadratic curve, y equals x squared. On my keyboard square, I have to punch in shift 6, 2, and that gives me the x squared. That is your parabola. If I shift it down, you see how it extends to infinity. We can keep squaring any number that you can think of, you can square and get the number times itself. So just like the two lines we looked at a while ago, they continue to infinity. This curve also does the same thing. It begins at the origin. 1 squared and 2 squared is 4. So when x is 2, y is 4. When x is 3, y is 9, because 3 squared gives 9, and so on. So this curve is called parabola. Now I want you to look at what happens when I get the y equal negative x. So remember, what we have on the screen now is y equal x. So y equals negative x squared. And y equal x squared is y equal negative x squared. You notice these are also opposite or inverse to each other. So just as a line y equals x, the inverse of the line y equals negative. Likewise, the curve y equals x squared is inverse to the line y equals negative x squared. All right, so let's look at some others. And when you download algebra, you'll be able to plot kinds of graphs and solve simultaneous equations by plotting graphs, and you'll be able to do a number of things. All right. Let me clear. All right. Why are all this coming up on the screen? So I'm going to know what happens to graph, and you're going to be able to just do some experiments and see what happens to a graph when you do this way, that way. So we're going to start by looking at a simple line, y equals 2x. So y equals 2x. All right, that's the line, y equals 2x. What would happen? Look what happens to the line if 3 to it. Y equals 2x plus 3. So let's plot that line. Y equals 2x plus 3. So what happens to that line? Look at the difference between y equals 2x, y equals 2x plus 3. Let's do another line for comparison. Let's do y equals minus 3. Let's do that line. Y equals 2x minus 3. All right, so those are our 3 lines. The middle one is y equals 2x. When you add 3 to it, you notice it's the same line, but it just shifts up 3 spaces. You see that? So this is the line equals 2x. And it's up 3 spaces because it's 2x plus 3. The line y equals 2 minus 3. From the original y equals 2x, we shift it down because it's 2x minus 3. How about the line negative 2x? What do you think will happen to that line? See, it's the opposite or of the line y equals. And in GeoGebra, you can go in and you can coordinate the colors, so you'll get the colors for your lines. You can set it so that the equation or the function is written along the line. You can get your geometric shapes, your polygons, regular polygons, your perpendicular parallel lines, angles. You can draw angles, and you can actually get calculation for your angles. So you can do your trigonometry, geometry, a whole ton of things. And we're going to be using this software. I'm going to be showing you how you can get all of this. Show you how you can manipulate your graphs. I wanted to show you those basic graphs: the y equal x, y equal negative x, y equal x squared, y x squared. Those main ones you're supposed to know. As soon as you be able to recognize it. So what we're going to do, I'm going to stop sharing this and I'm going to go to the board and we're going to plot a linear graph together. So what is a linear graph? A linear graph is a function that produces a straight line on the plane. How do you know a linear graph when you see it just by looking at the function, just by looking at the equation? The highest of the linear graph is 1, which means that the variable, usually x, will not have a number written on top of it. Like, for example, in the quadratic, you would have x squared, or in the cubic function, you would have x cubed. In the linear function, the power of the x term is actually 1, but we don't have to write the 1. So it's almost as if there isn't any, you won't be seeing a power or an int or an index. So once you see, for example, y equals 3x, y equals negative 5x, y equals x plus 7, y equals 10x minus 1, all of those are linear equations. Y equals 5 is a linear, it's a straight line. So that's what we're going to be doing tonight. And I am really hoping and praying to see the board clearly. For some reason, it doesn't seem to be working. So fortunately, you're not able to ask your questions in real time. But I still want you to post your comments because I definitely will be getting back and looking at your comments, your questions, and answering them. I'm very dedicated in that respect. I answer all the questions of my scholars. So even though the chat isn't working right at this very blessed moment, still post your comments and your questions. I'll get back to them. Alright, so we're going to plot a linear graph. So let me try to get this laptop closer to the board. Alright. So guys, here's our equation. Y equals equation, and this is known as the domain. The domain tells us where our x values will start and where they will stop. Now, since our we're drawing a straight line and adjust this, so you can also see the board as well as see my beautiful face. All right. So because it's a straight line, we really only need 2 points to connect. If you're drawing a straight line, you just need 2 points, and you connect them and you get your line. But we use 3 points because we like to see what's happening at the origin. So we use the 0 points as well. So we're going to set up our table, and we're going to put the -3, 2, and put 0 in the middle. Now we go back to our equation, which tells us what to do with our x values to get our y value. So it says multiply the x values by 3 and then add 5. That's what we're going to do. That is 11. All right. So these are our points we're going to plot. For the coordinate pairs, so it's -3 to -4, 0 to 5, and 2 to 11. That screen went a while ago. The biggest y value is we can up by 5 on the y-axis. That's our scale: 5, 15, 20, -5, -10, -15, -2. So that's our y-axis. On the axis, the number is smaller on the x-axis, so we can space out the scale on the x-axis more. So we can go up by 1 on the x-axis because this goes to the -3. So we can have 1, 2, 3, -1, -2, -3. So now we're going to plot our pairs. So it's -3 to -4. So -3 on the x-axis and down to -4. So negative or -4 is there. And 0 on the x-axis goes to +5 on the y. So 0 is the origin. So from 0 on the x up to 5, So 2x, from there we go up to 7. Of course, if I was using the coordinate plane, the graph paper, it would be accurate. Here on the board, so these are my 3 points, and I'm going to connect them. I should be using a ruler. So when you're in your graph, one you use in your coordinate player, the grid that you would have already bought, have your graph paper, and 2, using your ruler to connect the points. It's a linear graph, so it's a straight line. We're going to pretend, we're going to use our imagination and pretend that it's a straight line. Now, the last thing we do is to write our equation, our function on the line. So we write y equals 3x plus 5. Y equals 3x plus 5. So let's recap, and then what I'm going to do, I'm going to plug in this equation into GeoGebra, and we're going to see if this is what it looks like. We're going to see if this is what GeoGebra got as its line. So we were given the function or the equation y equals 3x plus 5. It's a linear equation because the highest power is 1. This is x power of 1 for x. The domain are our set of x values. It tells us where x values start and where they stop. Because it's a straight line, we don't know all the values in between. We just need the 2 end values, and we all throw in the 0 because we want to see what's happening at the origin. Is always good to know it on. The origin is where it's at the center of it, and we like to know one there. So we use those 3 points, the -3, the 0, and 2, and then we're going to plug those values into our function. We have to multiply x values by 3 and then add 5. So we did that. Each of these by 3 and these. When we added 5, these are what we got. We took our coordinate pairs, which are our x and y values. So 3 to -3 to -4, 0 to 5, and 2 to 11, and we plotted. So -3 on the x, down to -4 on the y, 0 on the x, up to 5 on the y, and 3 on the x, sorry, 2 on the x, up to 11, and then we use our imaginary ruler to connect the 3 points, and we got our imaginary straight line, and then we wrote the equation along the line. Now I am going to plug in that equation in my GeoGebra software, and I'm going to see if the line that I get. So again, I'm going to share my and bring up my GeoGebra, and then to get a clean page. So go to new, anything. All right. So I'm gonna plug in. So it was y equals negative. Oh, sorry, 3x. 3x plus 5. Ta-da! There it is. x plus 5. So it crosses, here it is, it crosses the y-axis at 5. It goes up to, see, it goes up to 11, where x is 2, y is 11. See right here, that's the point. See how accurate it is. And when x is negative 3, y is negative 4. There we have it. So that's our line. That's y equals x plus 5. Okay. As you can see, the algebra is very accurate. Show this, guys. The GeoGebra wasn't showing on the screen. Let me know if you saw what I just did a while. If not, I'll do it over. Those in the chat, what I did with the GeoGebra a while ago. All right. Okay. Who else you want to see in the chat, Alexander? Who else you want? People, well, you need to invite those persons to come. But Alexander, the studio is still, you know, there's a limit to how many persons are in the studio. There are other persons watching on YouTube and watching on Facebook. So if you want studio to be among the first steps, come on. You need to invite your friend. All right, so students, just to recap. Yes, so I'm saying to get into the studio, you have to use a special link. Those, but you have to start watching the video live on Facebook, on YouTube, on Twitter. They're not in the studio. You are in the studio along with Imani and John and Amari. And I think Madison, oh no, left. Madison left. And you'll be on the screen with me. You have to let me know, and then I'll just put you over on the screen with me. So that's the option for myself scholars as well. If you want to be on the screen, I can just turn on your so just let me know if you want to be up on the screen with me talking. All right, so just to recap, so we look at some of the special graphs that you're likely to see at this level. And those 4 graphs in particular, I want you to know them by heart, as we say. Know them by heart. As you see them, you'll be able to identify them. Line y equal x. Maybe I should go back and, maybe I should go back and recap so that you can see. So just to recap with those four special lines that I want you to know by heart. So anywhere you see them, know them, and you're going to be seeing them a lot. So here are the two inverse to each other. Y equals x. So y equals x, that's line. Then y equals negative x. That you must know those two lines by heart. Look at them carefully, memorize them, dream of them tonight. So the one that's right, that's y equal x is y is. This one oriented to the left, y equal negative x. What is x is the negative of it, and vice versa. Let's refresh our memories for the quadratic. Equal x squared and y equal negative x squared. So let's look back at those. So y equals x squared. With the square on your keyboard, just put 2 and you'll get squared. So that's the line, the curve y equal x squared. Remember, curve is a line, a curved line. And then y equals negative x shifts to negative x squared. So look at those, and they go on to infinity. They get bigger and bigger in both. See that? Infinite. Look at that. Bigger and bigger and bigger and bigger. Now you can scale down, you can out on the GeoGebra, right? Just click and it will zoom in. Just download it and play around with it. Download, it's free. GeoGebra is free to download on your laptop, and play around with it. See what you're able to do. Right? What you're able to do. Maybe you can come on and teach me something. Me what to do. Because like I said, this is not a tutorial on GeoGebra. I don't know enough about it to do a tutorial on it. I'm still, learning the ropes as I go, but I definitely enough to teach you this. And so this is one of the softwares we're going to be using, particularly in our graph class, geometry class, some aspects of algebra and trigonometry, right? So yes, this is where we're going to wrap it up for tonight. And you were able to join me. And unfortunately, the chat won't. But I implore you again, if you have questions about of the graphs that we've covered tonight, drop your question, comment. I will definitely respond. It doesn't matter how long it takes. I'm respond all my students, my comments. So while we wrap up and that video from the schedule, because some persons are still not familiar with the schedule of the classes. Tomorrow, I want you to join me. For the PEP students, we'll be doing the ability test. And for the CSEC students, we'll be doing algebra. All right, so we have introductory algebra class last week Tuesday. So tomorrow we're going to dive further into the algebra. We're going to be looking at substitution. So you don't want to miss that. You want to catch classes. So you're going to have the fundamentals, putting in the groundwork right now in the introductory classes, we're laying the foundation, so you don't want to miss these. And further along, you're going to be building on all of that. All right, so scholars, take care, and I'll see you for the other lives. Bye, guys.
Hello, CSEC student. I know for your maths and the CSAMs coming up. You have a very busy period for your math test and the CSAMs coming. I have a very important ask. Do you like? No. No, another important question. Simply because monitoring. Have you ever math problem wrong? Series where we're simply because of making one little mistake. I'm sure you have as thousands of others. All in to look at students have. Now in this series we're going to be looking at show you the mistakes that students make with every video in this series so that we can have all the topics in CSEC math we're going to look at making those mistakes. The common errors, demystify everything, every video in this series that we can avoid making those mistakes. So, stay tuned. Students get problems wrong. One single error. Well, it is absolutely true. Hello, scholars. Did you know that most times at the common that students get problems wrong in mathematics in the difference in mathematics? No one as a result of one single error or one mistake. It's absolutely true.
Okay, colors, I'll see you tomorrow.